DCC model railways can be complicated enough, but what can train automation and block detection bring to our hobby? Hi, welcome back to Chadwick Model Railway. I'm Charlie. Now, I've received many requests to do this video on block detection, but let's get things straight from the start. This is an intro into block detection. It just gives you an overview. It's not going to go into the deep realms of exactly how locomotives run and speed profiling and all those bits that go with it, and perhaps I'll cover that in a later video some 6 months down the line. Now, there's no doubt in my mind that there are people watching this video that have forgotten more about block detection than I would probably ever know. But what I'd like you guys to do is just to leave a comment, and the comment please to consist of which hardware you use, whether it be Digitrax or Lens or DigiKeys or whatever, and also what software you use, whether it's Train Controller, JMRI, iTrain, and of course if you get on with it, and if you recommend it, and if you believe it gives you good value for money and efficient running characteristics. Is it exactly what you thought it would be? So before you, the guy who's thinking of getting into train automation, dip your toe in that acidic bath, hopefully by reading the comments you'll have a better idea of what you're getting yourselves into. So what can block detection do for you? Well, it gives you the ability, just like the real railway, to have a computerized system knowing exactly where all your trains are at any given time, and depending how much money you spend, it might give you the facility to run those trains in a drag and drop kind of world, or perhaps to them to follow routes, or indeed full automation, whereas you can click a few buttons and the trains will go exactly where they want to go. You might not choose the routes, you won't even choose the points, they'll just find their way around. But why would you want that in the first place? Well, if you've got a very small layout, I suggest you don't want it, because it will dominate your layout, and it takes away the intrinsic value of you getting your fingers involved and playing with your own trains. Of course, DCC, you drive the train, DC, you drive the track. So there are always going to be a fundamental difference. And whilst I mention it, I cannot find any block detection system that works on DC. If you're a DC kind of guy, then you either need to make the jump into DCC or look into more complex shuttle systems to give you some kind of automation. It must be serious now, because I've got my notes. So what can block detection really do for you? Well, David Townend from McKinley Railway, in conversation a couple of weeks ago, just mentioned and put it very profoundly that his railway hasn't got a colliery and it hasn't got a power station, but he's got coal trains. And so he referred to his coal trains as scenic trains. They are trains that just appear, they run around the layout and they disappear. I have tankers, I don't have a refinery. So why do I want a tanker train? Well, it's just, again, it's a scenic train. It will come up from the fiddle yard, do a lap, disappear back down, and then might reappear again another 10 minutes later. But whilst these trains are trundling around with no real visible destination or purpose, the trains that I want to run, which might be an assembled freight train coming from my branch station, or locos coming out of a loco shed to pick up a Freightliner train, these are the fundamental construction of trains that I'll be doing, or me and a colleague, whilst the scenic trains make their passage around the layout. And that's really an advantage of train automation, block detection and all that stuff, because it makes your railway, if it's big enough of course, very interesting with the passage of trains that need no human intervention, if that's what floats your boat. If your layout is small, then you don't really need to go down that avenue, but if you wish to step up to block detection, then hopefully you can see the advantages. A word of warning, of course, and that's cost. This is, it could be a very expensive evolution, and I shall go into the costs at the end of the video. Complexity is another thing worth considering. Your electronic skills don't need to be that well developed, but you do need to have not a fundamental engineering background, but you just need to be aware of how some of these manuals are written. Some of them aren't that easy to understand, or perhaps a network of friends who are into this sort of stuff, because it's not quite as basic as you might think. The electrics and the minor electronic sort of aspects are worth considering. It's time consuming. The wiring for the system that I use, the current detection system, can be quite complicated. And another word of warning is once you get into it, it can be quite addictive. You know, you want to try to get, I can't get that signal, a 4-aspect signal to run properly, and you're trying to write the sort of code into systems and this sort of stuff. And once you've sorted one particular snag, it can be quite rewarding. I want my trains to sound their horn as they go into the tunnel, or I want my sound to switch on as a train comes out of its fiddle yard. I want the guards van lights to work, and all these fundamentals that DCC with block detection can bring to the hobby. But as I said, it can be very addictive. I mentioned I'll cover costs at the end, and that's the costs not of the hardware. I'm no expert on how much a complete lens setup will cost. I do know how much the Digitrax system costs, and I will run into those. And I've also done a little bit of work with DigiKeys to give you a sort of an overview there. And also the 3 systems that I'll consider, which are train controller, which comes in 3 stages, JMRI, which is free software, and iTrain, which comes at 4 different levels. So we'll look into those at the end of the video. So block detection, and how can that work? Well, let's say you've got a piece of track and there's a point at one end and a point at the other, and in the center of those 2 points is a block, and you wish to detect a train's presence. So there are 2 systems really. There's using things like momentary sensors such as dots. So the loco would come off the point into the block, it would be detected by the dot, make its way through that block, and then as it departs at the other end it would go over another dot, and your software would detect that, your hardware would detect it, go through your system into your hardware, and it will come up on a computer screen as that train passes through that block. And that's a system that I don't personally use. I use current detection, and this involves isolating certain sections of your layout. So your train would come off the point, and there would be a insulated rail joiner, so it would come onto that section of track, and its presence would be felt because there would be current detection. It would be pulling current through a certain circuit, and through hardware and software, again, your computer system would be able to figure out which train it is and where it is, it's the speed it's going at or whatever, and then when it goes off the other end and it clears that section through yet another insulated rail joiner, then your train has departed. And that is the fundamentals of block detection on a current-based system, which is what I shall go into next. Now on the upper level of my layout, it's wired so that it's on black to the back. That is, all the back rails of all the tracks are fed with black cables, as it were, and they go on to the black cable bus wire. But all the red cables are the cables that go individually into blocks, with the exception of points. Points are not included in blocks, and some people will disagree, but I gave you that health warning at the beginning. But none of my points are included in blocks. They are all independent. So we then need some kind of hardware to get the power from the red bus cable, let's say, into those individual red blocks. Now this is a BDL 168 made by Digitrax, and as you can see, these red cables are the ones that go off to the red rails, and there's also a couple of cables for power in just to run the base of the board, which is between 12 and 18 volts AC or DC, and also you have the power going in from your red bus, as it were, that then gets split into these 16 feeds that go out. There's also a Loconet cable in and out where you daisy chain Loconet across. That's what provides your software with the information of where your trains are and exactly how your system is running and operating and online, etc. There's also some terminals here of which you can fit these small indicator type LEDs, and it will show you which circuit to switch on and which of these circuits are actually occupied. So there are 4 LEDs and they will come on when each of the blocks is occupied, and obviously there's 4 there, and you can fit this onto the other terminals. And if you had 4, you could monitor all 16 of the blocks independently. This clearly involves a little bit of soldering, which is hazardous in itself, but if I pull that off, and if you put your hand in your pocket and you go to a company called Aculights, you can buy something known as a breakout board. And this makes things much more simple because you've got your ground or your earth cable coming in, you've got your power, as I said, 12 to 18 volts, either AC or DC, and then you've got 4 inputs. Should you be using power districts, or you just use one input and then daisy chain them across, goes through the gubbins of the board and comes out on your 16 terminals, which then go out to your rails. It's a straightforward component, or it needs to be programmed, and you have some programming switches and all that kind of blah. BDL 168 from Digitrax. Now here's my faithful old Dell laptop. It's not exactly leading edge technology, and you can see there over on the right hand side 4 throttles for selectable locos. Underneath and the bottom there is a table of locos, and more importantly over in this corner here is the track plan. Now it's probably worth mentioning how easy or how difficult it is to draw these track plans. Well, as you can see, it is pretty straightforward, and I'm sure, various track plans have various forms of complexity, but this really is pretty straightforward. Got that bit wrong, didn't I? There we are. Take that on, and we can have a siding here, and let's have another passing loop here. And the points are laid in automatically, and of course we need to add some blocks, if I can find where they are. And it is worth mentioning that you can't add blocks to the diagonals. They kind of look a bit odd in a previous version, but clearly you can't do them now. Anyway, all you need to do then is this is a bit of an eye candy really. You just open them up to suit, but whatever your railway is, it kind of works. It's all interesting stuff. If you wanted a sort of loco shed design, and you can adapt it to your railway, and yeah, very easy, very manageable, and all straightforward. Now this area of the track plan is yet to be built, whereas this one has been constructed, and you can see these yellow and pink blocks which represent the block for block detection. Underneath this layout there is also, if I can get my mouse to work, another track plan which is the fiddle yard area, and once again this area here is yet to be built, but this area here is almost complete. So what does it represent? Well, if you can see there that platform 2 is pink, and the reason why is because in platform 2 is Western Firebrand. And similarly, if I were to put a shunter onto one of the other tracks, you should see it change colour, because it has a DCC chip in it and it draws current. Now you can see that on station fast inner, where I've put the shunter, it's now present. What it doesn't have with the Digitrax system and train controller is transponding. So the system knows the shunter is there, but it actually doesn't know what is there, and I have to manually take the shunter from the list underneath and plonk it onto station fast inner. So now when we send this shunter on its way, the symbol will go with it because the system understands which locomotive is present. Well, hopefully that seems straightforward, but of course it does leave you with the issue, well, how does all this information about occupancy get back into the laptop? Well, that's done by a system known as Loconet. So now, looking underneath the board, we'll see one of my little drop-down boards which contains a couple of DS64s which control the points there, and also a BDR168 which I've labelled as number 1. And hopefully you can see that between these items is daisy-chained a cable. And it's a 6-core cable, and it goes back to the controller DCS240 and then via USB up into the laptop and then into train controller. Now all the systems with Digitrax, and I'm sure it's the same with other systems, are looped in with this data flow system known as Loconet. Loconet is a Digitrax copyrighted term, but it's been adopted by many other manufacturers. I believe Lens use it as well. So getting back to how it works then, so here's the power in, as I mentioned, is between 12 and 18 volts AC or DC, and this makes the BDR work. It also has an earth cable coming from the main controller. There are 4 feeds coming in, which are the red bus cables, because I split mine into districts. So there's A, B, C and D, and then the feed for A, this one here, will go out on block A, on B, C, D accordingly. And the guts of how this works is beyond me, clearly, but when these obviously would normally be your main bus wires, it gets split off into those 16 feeds and goes off into 16 individual pieces of, in my case, front bits of track. Now, if that wasn't enough, let's take it a stage further. So we now have a block, and it's fed from one of the outputs of a BDR168 or some other device from another manufacturer. And as soon as the train goes into that isolated section and draws from that power, then a signal is sent via the Loconet cable back out to the system and then eventually back into the laptop, which turns one of those green blocks red. Easy. It's not quite as simple as that as you'd expect, because most people would agree, that means there's loads of people that disagree, that each block should actually have 2 feeds in isolation. So that means that each block has actually got a cut within the block. So there are 2, if you like, isolated, I don't want to use the word block, but sections within that block. So each block ought to have 2 sensors. But why would you want that? Well, quite simply, if you're in a single direction running, the train would come onto the block. But if the next block were to be occupied and you want that train to stop, then you have to start specifying orders to the train so that the DCC decoder will understand what it's got to do, because you will specify in the block how far you want it to go and then when you want it to stop, to save it running out of that block and crashing. And this is how it's done. Now this piece of track here is known as Red 1. In the past I've called my blocks some really stupid names and regretted it ever since. But Red 1, it comes up from the helix and ends at a point which goes into the viaduct. And just to show you the length of that, Red 1 starts right back here. So I can get a decent sort of 8-10 coach train along this track into Red 1, and I don't have the risk of this train stopping in other blocks as it's going along. And it has an insulated rail joiner both at the start of Red 1 coming off the helix, as you can see just here, and also at the other end where it joins the viaduct, just here. Now I've measured Red 1 and it's 12 foot long, which is just under 4 meters in length. a substantial piece of track. And I want that train, as it comes up here, to stop in this area here, because I'm going to place a signal in front of it, and I want to make sure that we've got a safety margin so it doesn't run across those points should there be traffic in another direction. So I want a cut around here. And here is where those two isolated sections are, separated, as you can see, by an insulated rail joiner. If you look just a little bit further along the rails, you can see the power feeds coming up, which feed the second part of Red 1. If we look further down the tracks at Red 1, then there'll be various feeds going out to the individual pieces of rail. Getting underneath the baseboard, we can see yet another BDL 168, this one numbered number 7. And as we can see, some of the cables going in the top, in zone C, you'll find Red 1 and Red 1S. Red 1 being the main track, and Red 1S, S standing for stop, is that top section just before the viaduct points. So now we need to get all that information into Train Controller. So what we need to do now is go to the properties of block Red 1. And as we can see, there's some data entered of which the train needs to be aware. I mentioned that it was a 12 foot long, 144 inches. Well, what I've decided is the train will come in for about 80 inches and then slow down to a crawl speed of about after 120 inches, and then when it hits this stop mark here, the brake mark between the two blocks, it should stop as soon as it detects current on the front bogie on the next sensor input. So that's the main length, and this is the short length. If we click into here and go to its properties, we can see that its address was indeed on BDL 168 number 7, and it was on terminal 12, and similarly its running mate was on number 11. Well, that's all well and good, but let's see what happens in reality. Now for this exercise, we've got my class 50 halfway up the helix, ready to go, pulling a rake of 8 coaches. And as we look into Train Controller, we can see that in the block east helix outer 4 and 3, because of the length of the train, is that class 40. And the idea is I'm going to do a drag and drop, and it will run up through level 5 into Red 1, through some ridiculously named blocks called 1 fast inner, 1 fast inner, 1 stop, and station fast inner. I told you I had some stupid names, and it should pull up there and stop. So that's the plan. So first thing I need to do is click out of edit mode and then go to drag and drop. And then what I shall do is drag and drop this into that block. But just to make things a little more interesting, I'm going to place a brake van on top of fast inner 1. So now hopefully you can see that block turn red, and the reason it does it is because the brake van that is now here has LEDs and it draws current. So now all we need do is set off our class 50 and see if it pulls up. In Red 1, because its path to the station is blocked, so with a quick drag and drop, I take it and pop it into station fast, and off goes our class 50. As it climbs the helix, obviously you can see on Train Controller it works its way up, and the blocks will change colour as it makes progress. Its route is mapped out in yellow. But now there is a red light in front of it, and that's because of the guard's fan is blocking its route. So if we come and look at our class 50 as it comes over the top of the helix, and then we're concerned with where it should stop. Knowing that there is a fictitious signal, it should stop just about here. And this is where the insulated fish plate is. So the bogie comes across, power is drawn from the next sensor within Red 1, and the loco stops. Absolutely ideal. So what happens next is we remove the guard's fan. I take away the guard's fan, it disappears from train controller, and the class 50 proceeds on its route. It goes across the viaduct. Obviously it changes colours as it occupies those blocks and eventually works its way across into station fast outer. And there we have it. Easy. Now I mentioned earlier that we can actually influence the locomotive's decoder by making program changes to the blocks themselves. Now we've looked at Red 1, so this time I've got the first sensor of Red 1 to turn on the locomotive's sound, lights and a delay of 1 second, and then blow its horn as it would come out of the tunnel mouth from the helix. And furthermore, as it hits the second sensor section of Red 1, it will blow its horn once more before it transits the viaduct. So I've done this with a Pullman, so let's take a look. So here it comes, just about to hit the start of Red 1. And once more the horn blows as required. Well, hopefully you enjoyed seeing a couple of trains running around and understanding how the block detection side works. If you're not going to get into block detection, that's all well and good. But if you think you might do in the future and you're just about to start building your layout, then perhaps wiring it as such that you can go to block detection at a later date might be an opportunity. Let's say you don't have to go and buy all the equipment, but the wiring would be in from day one. So perhaps something to keep at the back of your mind. Now, let's talk about money. Dreadful thing. I spoke about the hardware, and this being a BDL168 from Digitrax. This little unit is on sale today for 145 quid. It's an astonishing amount of money when you consider what you can pick up from China these days, let's say, but it is what it is. 16 outputs, 145 quid. I must confess I buy most of mine second-hand on eBay, and you might buy one a bit cheaper because one of the 16 outputs doesn't work. Might be worth it. This board from Aculights isn't necessarily essential. You can always solder on and you know, go for it that way. But that board itself is £40. So this whole thing is 185 quid. And I think that's a huge amount of money, especially when this might only accommodate 8 blocks, because each block might need 2 sensors. And you might have dozens and dozens of blocks around your railway. So What else is there on the market? Now, this is a time for glasses, I'm afraid. So, DigiKeys make a similar 16 output sensor, and it's got a catchy name. It's a DR4088LN-CS. God knows why that is. That retails at £64.05, and again it has 16 outputs. And if it's reliable, why on earth would you go down the Digitrax BDR168 route when you can buy 3 of those for the price of one of those with the Aculite board? It's a no-brainer to me. Of course, if you're committed to Digitrax already, then that's an avenue you really can't go down. But if you're going to start from afresh, do your homework. I'm always in contact with DCC Train Automation, and James and Ed know their stuff. Give them a ring before you want to spend any real cash, because you need to do all your homework and price out the whole project before you commit. I can't really give you any more advice on companies like Lens and ESU and all this stuff. I really don't know, and I'm not an expert, and I don't intend to be an expert. But the fundamental thing I'd like to mention to you is I am not recommending anything, but I do enjoy my own automation. And then we get on to the software. I've only come across 3 companies that make the software, but there are loads out there. And JMRI, which I'm sure you've all heard of, is a free download. Although it's a steep learning curve, let's say, to get to grips with JMRI. It's not the easiest program in the world to fathom out, but if you can run a layout like this for free with JMRI, why wouldn't you? Well, I can think of a reason, because how much time do you have to spend on it to get it serviceable, up and running? And then there's not the new kid on the block, because iTrain has been around for quite some time, but iTrain comes in 4 different price ranges. There is Light, Standard, Plus and Pro. Now, iTrain Light comes in at £110, but it doesn't give you the full automation. Your trains will run on routes, but doesn't give you the flexibility as you've seen here today of dragging and dropping and schedules and all that palaver. But for 110 quid, it might be something you weren't worth consider. You can upgrade from the levels in iTrain, and if you go from the £110 light and you go to the £182 standard, which obviously gives you more functionality, and then that gives you all the automation side of things. But if you upgrade then from 182 to 234, you get into iTrain Plus, and then from 234 to 325, you get into iTrain Pro, which apparently has all the bells and whistles. And I know many people who are considering going down the iTrain Plus route. Now, you might not be aware of what I'm using here. This is Train Controller Silver, and I invested in this quite some time ago. It was considerably cheaper when I bought it, and I think I bought it probably about seven, maybe eight years ago, something like that. It's Train Controller Silver. And here is the breakdown of Train Controller software. So here we are on the Train Controller software website, and all you simply do is pick your country and the price will come up. So let's pick a country. What do you fancy? Let's go to Argentina. And Argentina is, for bronze, it's $154 US, 474 for silver, and $699 for Train Controller Gold. These clearly are far more expensive than iTrain, but if you want these things, clearly you have to pay. Now, I did have a little whiz around the world just to see if there were any different prices, and there does seem to be the odd inconsistency, let's say. So if we go to the US, and here we find it's actually exactly the same, 154 for bronze, 474 for silver, and £699 for gold. Well, if these things cost that much money, then perhaps so be it. But invariably, you get what you pay for. Of course, we're over in the UK, so let's just check out the UK prices. And like me, you'll be mortified to notice that bronze is not $154 to us, it's actually $220, Silver is 639, not 474, and gold has gone from $699 to $930. These are staggering differences. And for me personally, if I wanted to upgrade from train controller silver to gold, it would cost me $383, which is more than, well, it's not more, it's $99 more than I would pay in any other country in the world. And I find this difference staggering. And if you know why this difference exists, then hopefully you know where the comments section is. And just to let you know, this is my train controller silver manual, and it's basically 500 pages of double-sided printing. It's one hell of a beast. I just want to clarify one point that I made earlier, and that's about the prices of iTrain. The prices I gave you were for the individual versions, not the upgrade versions. So if Plus costs you 234, Pro would cost you 325. These are outright. That's not the price to jump from Plus to Pro. That's a much smaller increase. And I've done a bit of maths. iTrain Pro in dollars is just about $450, which is less than half the price to UK modelers for train controller gold. I find it, the whole matter, not bewildering, but just staggering. Okay, hopefully you enjoyed that. Please leave a comment in the comment section below, especially if you're an established automation kind of enthusiast, let's call ourselves. I'll be interested to read your comments, but more importantly, so are the other people who are interested in our marvellous hobby. Right, in case you're fed up with all this geeky wiring stuff, in 2 weeks' time we're back to landscaping, so something for everybody hopefully. And in the meantime, I'd like to thank the people who donate to the channel. Without your support there wouldn't be a channel. And of course to my patrons, if you'd like to become a patron, there's the button. If you haven't subscribed, you know where it is, and a video here and here. See you in 2 weeks. Take care. Bye-bye.